The imager for Mars Pathfinder is mounted on a mast which supports the camera 1 meter above the Martian surface. The camera designers deploy the camera manually to check its operation. On Mars, this action will take place in less than 1 second. The imager will acquire panoramic images of the Martian landscape surrounding the Pathfinder. It carries 23 color filters that will be used to analyze the composition of surface materials and to investigate the properties of the Martian atmosphere. After landing, sensors mounted on its deployable boom measure temperature and wind profiles. Winds are also monitored by photographing a set of 3 specially designed windsocks. An alpha proton X-ray spectrometer will be carried to selected rocks and soil samples, permitting the first surface measurements of the elemental composition of Mars rocks. Richard Blomquist demonstrates the deployment mechanism that positions the sensor in correct orientation for measurement. The sensor retracts at the end of the observation, enabling the rover to proceed to the next sample site.
In its descent phase, Mars Pathfinder uses a disk gap band parachute system developed by the Pioneer Aerospace Corporation. Many different configurations have been designed and tested to achieve the high lateral stability needed to keep the rocket platform near vertical until ignition occurs. Here, an early prototype design is being tested in the presence of high winds near Yuma, Arizona. These tests convinced the parachute design team that increasing the size of the band yields a more stable configuration. In less than 1/2 second, the airbag is inflated to a pressure of 1 psi by a solid propellant gas generator. In the final seconds before making contact with the Martian surface, 3 solid rocket motors mounted on the inside of the entry backshell are fired for about 2 seconds. The design team needed to understand the dynamics of how the rockets interact with the lander, suspended some 20 meters below on the bridle, and with the parachute above the backshell. 3 test bridles have been placed near the plume to evaluate the effect the plume temperature has on the bridle material. The real proof of the airbag's performance came when impact testing was performed in the 120-foot vacuum chamber at NASA's Plumbrook Station in Sandusky, Ohio. A full-scale 800-pound test lander is shown here dropping from about 75 feet onto a platform in the chamber. Had this rebound occurred under the same impact conditions on Mars, the bounce would have been over 10 stories high. It's more likely that the airbags will impact the surface of Mars at a grazing angle. Here the test lander is dropped on a sloped platform studded with lava rocks. Once the lander comes to a stop inside its protective airbag cocoon, it must be deflated. The onboard computer does this by activating 4 airbag retraction winches that open up sealed vent holes inside the airbags so that the lander pedals can be safely deployed. Winches are also used to pull the airbags toward the lander via small internal retraction cords. Once the airbags are retracted, 3 high-torque pedal actuators open up the lander pedals. As they do so, the lander will automatically orient itself so that the lander is upright. Although not shown here, the rover, attached to the inside of one of the pedals, is now ready to drive off of specially designed ramps that deploy from the pedal.
The operator doesn't see it. What happens is here. The rover goes along and has laser lights spread over there. The cameras in front over there. You don't want to do it?
Airbag retraction, the Pathfinder rover is ready to conduct its mission. Ramps are deployed to allow the rover to drive without hang-up over the remaining airbag material surrounding the lander. Pyro firings release the attachment fixtures to the rover, and the rover is then commanded to stand up. In driving the rear wheels while the other wheels are locked, the rover locks its bogies and establishes its deployed configuration. It's now ready to drive down the ramps and begin its mission. The rocker bogie design of the rover allows the vehicle to negotiate a wide range of terrain conditions. The rover can drive over rocks greater than a wheel diameter in height and soil mounds at the angle of repose. A single wheel can lift the weight of the vehicle, providing recovery from hang-ups on obstacles. While traversing over the terrain, the rover lays down track patterns, image ruts, drives its wheels, estimates its distance from the lander, and, in general,
The Delta rocket with Mars Pathfinder, and the vehicle has cleared the tower.
We have a poorer ability to locate the planet. Once Pathfinder is on the surface, we'll be able to refine our understanding of exactly where Mars is in the sky.
Copy that.
On NASA TV is Rob Manning, the Flight System Chief Engineer, obviously in good spirits.
EDL Telecom reports cruise stage separation. All right, this is the Mars Pathfinder flight director. We have confirmed that cruise stage separation has occurred. The digital data stream has ceased, and carry mode has begun as expected.
For those listeners, I want to explain that for a few seconds just after cruise stage separation, the cruise stage physically blocks the entry vehicle's radio antenna for its view back to Earth. This causes interruption of the signal that we can see in our monitors of signal strength with the Deep Space Network. The cruise stage will fall behind the entry vehicle for the rest of the entry phase. By the time that the entry vehicle begins to feel the forces of the atmosphere, the cruise stage will be about a half a kilometer behind. EDLCom reports that the Earth is now rising at our landing site in Ares Vallis. As those of you who have been listening have already heard, about an hour ago, we vented Freon that's been circulating around the vehicle for the past 7 months out into deep space. Because the lander and rover electronics are so well insulated from the cold of the Martian atmosphere, we had a challenge to keep the vehicle cool during the 7-month voyage to Mars. The solution came up was to pump Freon, liquid Freon, around the cool outer periphery of the circular cruise stage, then route this Freon back inside through plumbing into the lander and past the rover. Seconds before separation of the cruise stage, the Freon tubes and electrical cables that connect the cruise stage to the lander were pyrotechnically activated by guillotine-like cutters. Other cable cutters will be used throughout the entry, descent, and landing phase, the standard process used in most launch vehicles as well. Now that the Freon has been expelled into space, the lander electronics will start to warm up. By the time that the lander and rover are safely on the surface, electronics were warmed up to near their maximum limit. This is among the reasons we turn off the transmitter after we land. The other primary reason is the fact that we're trying to conserve battery power for later on today and for overnight.
Team members and some NASA management individuals have gathered here, including Jim Martin, the former project manager for the Viking project, invited here to JPL. The mission support area is to the right in this field of view.
The next event will be entry, atmospheric entry, which occurs at about a minute and 16 seconds from now. This point is approximately 130 kilometers from the surface of Mars. It's the point where the spacecraft will begin to decelerate due to the force of the very thin upper atmosphere of Mars. 30 seconds till entry. The next event is peak aero entry heating and peak deceleration, which will occur in about 50 seconds. The spacecraft is now 80 kilometers above the surface of Mars. The spacecraft is now slowing down very rapidly. It's now 40 kilometers above the surface of Mars, traveling at 6.5 kilometers per second. By now, the onboard flight software should have used the measured deceleration profile to decide precisely when to open the parachute, such that the dynamic pressure at the time of parachute motor deployment is about 600 newtons per meter squared. Although the vehicle is still traveling at nearly 1,000 miles per hour at the time that the parachute deploys, because the atmosphere is so thin, this dynamic pressure corresponds to only a fraction of a pound per square inch. We expect that the parachute will deploy in about 15 seconds. The events will follow will occur in rapid succession under the control of the onboard software. I'll report these events as they are expected to occur. Parachute should now be deployed. The spacecraft is slowing down rapidly because of parachute deployment. The heat shield should separate in about 3, 2, 1, 0 seconds. The next event is lander separation. That should occur in about 5 seconds. When that occurs, the lander will descend in about 10 seconds down the bridle. Lander separation should have occurred right about now. We should be switching from one antenna to another antenna under a flight software control. This is an antenna that improves our ability to see the signal during this descent phase. The spacecraft should be approximately a mile above the surface of Mars. There's a lot of uncertainty in the timing from here on out because of the variation in the atmosphere. The spacecraft should have passed the 600 mark. Airbag should be inflated. Rockets should be firing. And bridle should be cut. Yes. DDL comments report that a signal is barely visible. It's a very good sign, everybody.
.25 Pacific time, a very exciting and historic day. About 6.5 hours since this Pathfinder spacecraft has landed on the surface of Mars. We've already gotten the low-gain antenna data, and we are now anticipating the return of high-gain antenna. which will transmit the pictures, the very first images from the surface of Mars in more than 20 years. A lot of anticipation in the mission support area as that first high-gain downlink session should begin momentarily.
We have closed-loop receiver unlock. We have closed-loop receiver out of lock. We have carrier back in lock. We have subcarrier and symbol in lock on the 70-meter station, RCP number 2. The carrier signal is 2 dB stronger than expected.
That is great news, Telecom. Just a short synopsis. This probably indicates that the camera has found the sun and has been taking images of
and they have indications that the high-gain antenna has located the sun. Locating the sun, of course, is essential for transmission of data from the high-gain antenna. The high-gain antenna will be transmitting the first images from the surface of Mars.
data. We have imaging data. Yes.
More handshakes and cheers in
We
the
have
motion
4
support
frames
area
in lock so far.
as the image.
Nipple, go ahead and process the sequence 22 airbag assessment images without the quaternion.
Without quaternion? Okay.
Flight Director Jennifer Harris has instructed the MIPL lab, that's the Multimedia Image Processing Lab, to begin processing some of the images that are being returned. We should be seeing them shortly. Again, these are the very first pictures from the surface of Mars in more than 20 years.
Without quaternion, correct?
Can you give us the status of the thermal subsystem?
Yes, all systems are within allowable flight limits.
Copy that. Can I get a rundown of the telemetry channel?
Sure. The SSPA temperature is 22.46. The HGA clock temperature is minus 28.67. HGA cone temperature minus 23.62. IMP camera head temperature minus 34.
We're back to more landscape.
I think everybody is just terribly excited that we're on the ground and we're getting pictures finally.
Everything has worked so beautifully today. I mean,
Flight Rover.
Go ahead, Rover.
Yeah, could you inform us when you're done with... Can you inform us when MIPL's done with processing on S2?
Yeah, we'll do that.
Roger.
Flight, this is thermal.
Okay, go ahead, thermal.
The IMP heater is indicating on now, and then the IMP CCD is heated up to minus 20, which is its operating temperature.
Copy that.
outwash on the Martian surface.
Which will be retransmitted at a later time.
Copy that. Attitude control flight.
Flight attitude control.
Can you verify that the accelerometer state sensitivities, the lander tilt, and lander quaternion are all correct as reported in telemetry?
It's really an exciting moment, not just for the Pathfinder team, but for the entire Mars program.
Right now we're looking in the rover control room, and you can see that the glasses that the operators are wearing, these are actually 3D virtual reality glasses. And by looking at the monitor screen with their 3D glasses, these rover drivers will be able to see the Martian landscape as if they were actually there.
Yeah. Wayne, it looks as though Brian Cooper, I believe that is currently analyzing the position of the lander using his 3D goggles.
Right now, they have a computer simulation of the lander based on the data that has come back in the last downlink session that completed the picture of how the lander was oriented with respect to the Martian surface. And right now, with this data and the photographs that are being processed by the scientists, the flight team is trying to get a good picture of whether or not rover deployment can happen tonight.
Even if the rover is not actually deployed, that is rolled off the ramps, they hope to at least get the ramps deployed and have the rover stand up, from its stowed position. That's for various energy reasons and thermal and cooling reasons. It's best to have it stand up as soon as possible. But again, the key issue is health and safety of the rover. This is Mars Pathfinder Mission Control. We've been watching the first images to be returned by the Mars Pathfinder spacecraft, which touched down on the surface of the red planet about 7.5 hours ago.